In this example, we want to look at interest compounded continuously. So we have $3,000 at 6% APR compounded continuously, the operative word here, for 7 years. Okay, so the old way of doing interest was compounded in times per year. Okay, remember that. Compounded in times per year. Okay, and that was this formula, A equals principal times 1 plus the rate over n, all to the power of nt. And we could compound the interest. Remember, compounding interest is where you take the interest that is accrued and you put it back into the account and then charge interest on the amount that's in the account, plus now we're putting the interest in the account. So we charge interest on the interest. And each time we do that, it's called compounding. So we compound it, once per year, means we do that once every year. We compound it every month, that means we do it 12 times per year. And the idea was we could do that every hour, every minute, every second. And let's take that to the extreme and compound the interest in every single instant. So every instant, we could take an account and take the tiny, tiny fraction of infinitely small interest and put that back into the account and charge interest on that. When you do that, you get a new equation, and in calculus, you derive why this new equation, or at least where this new equation comes from. But the new equation, and we call that compounding continuously, A equals P e to the RT. And this is compounded continuously. Okay, compounded continuously, meaning every instant we're taking that interest and putting it in there. Just to define the terms here, we have the A is the amount, that's the current amount. P is the principal. Okay, that's how much was initially invested. R is the rate, make sure you put that in decimal form. Okay, and T, of course, is time. Okay, and that will be in years in almost all cases involving interest and money. So I'm just going to say years. Okay, let's take a look at this example then. We have $3,000 at 6% interest compounded continuously. Okay, so here we go for 7 years. So $3,000 is the principal. 6% is the rate. Okay, but it's not 6. We move that decimal 2 places to the left, so it's 0.06. Always remember when you have a percent to move it 2 places to the left to make it in decimal form there. Okay, and then here's our time. There's T, all right, and then we just plug everything in. The amount is the principal, 3,000, times e to the 0.06 times 7. And I'm going to put these in parentheses, all of this in parentheses, to remind us that when we go to do this on a calculator, sometimes you will need to put this all in parentheses. Let's put it into a calculator and see what happens. So in my calculator, using a TI, I would put this in as follows. 3,000 times, okay, e to the power of button, that's to the power of, that's the caret button there, parentheses, 0.06 times 7, close parentheses. All right, put that all into a calculator, see what we get. We get about $4,565.88. Okay, there we go. Let's just see how different this is than if we were to compound it monthly, right? Because it seems like, wow, compounding it every instant would be so much more. So let's just check. So let's do this. Compounded monthly. Okay, that would give us A equals P, so 3,000. 1 plus 0.06 over monthly would be 12. All to the power of 12 times t would be 7. Okay, so putting this into a calculator gives 4,561. $4,561.11. Okay, so compare these two. This should be dollars as well. All right, yes, it's a little bit more compounded continuously over 7 years. What is that, about $4 more? So when it comes to the account holder, honestly, it doesn't make that much difference, at least not as much as it seems like it might make, going from compounding only 12 times per year to compounding every single instant. But you can imagine from a lender's point of view, over many, many accounts, this would make a lot of difference.